Hello everybody, this is lecture number 15, discharge standard as per CPCB, Central Pollution Control Board norms. So this is a third part of unit number 1. So myself, Arya Sarone, working as assistant professor in civil engineering department of SNJB's Letso Kantabai Bharlalji Jain College of Engineering Chandwar. So what are the content of today's lecture? You can see here. So today we are going to discuss about effluent discharge standards as per CPCB, that means Central Pollution Control Board's norms, interpretation and the practical significance of the test results. Then we will discuss about stream sanitation, in which that there is the first topic, self-purification of natural stream, then second, oxygen Sag Curve, and third one, river classification as per MoEF, that means the Ministry of Environment and the Forest, and CC of Government of India. So first, to point in today's lecture here, effluent discharge standard as per CPCB, Central Pollution Control Board norms, interpretation and the practical significance of the test results. Actually, I given here one website. So this website, which are made by CPCB department of one manual from this website we can download that manual, which is related what CPCB had put the norms, that is related to effluent discharge. So effluent discharge, that means meaning of this word effluent, that means dispose the wastewater into the stream, that is the effluent. And effluent, it is the came from the wastewater for the treatment purpose. The difference between I and E, effluent, that means it should be a discharge. So for effluent discharge purpose of CPCB having framed one manual, and that manuals, there are some norms which is related to interpretations, practical significance of the test results. And that's what I have put here one website. From that website, here it is one clear how to download that manual for the effluent discharge purpose. So these are the some CPCB norms about the practical significance and its result, which are already made by the CPCB department and which are all available on that websites. And how to download that manual, you can clearly mention in this website, which is on the YouTube. So in self-purification of a natural stream, this is the most important topic in unit number 1. When wastewater is discharged into the river or a stream, the BOD mix increase initially and the DO levels start falling. So we can very well know that when the wastewater discharge into the stream, at that time BOD increases. Already I told you in previous lecture what you mean by BOD. BOD is the amount of oxygen which is required for the organic matter for the oxidation purpose. Is that clear? At that time, the initial DO levels start falling in a stream when BOD mix with that stream or discharge into the stream. So mostly we can say in Marathi, that is when wastewater जर कदाचित रिव्हर मध्ये जर सोडलं त्या टायमाला त्याचा इनिशियल DO हा वाढलेला असतो आणि जो नदीचा डिझॉल्व ऑक्सिजन जे असतं ते तिथून पुढे कमी होण्यास सुरुवात होते. Now in the second sentence you can see here, as river water travels further, BOD gradually reduce and DO increase and reach its saturation level. So it is very simple again, that if your BOD gradually reduces when the river water already having its DO, and automatically by natural mixing of that water, DO increases and the reaches its saturation level. And at that time BOD gradually reduces. Thus river get purified on its own due to these things. Is that clear? thus river get purified on its own. So this phenomenon is known as self-purification of a stream. It's a very simple phenomenon. That is, once BOD mix with the river and river get DO level falling down. But in availability or atmospheric free river water having some DO, and which is automatically increases once that is mixed with the natural DO, natural oxygen, which automatically increases the oxygen of a river, and at that time BOD will be the reduces, and thus it may get self purified. So this phenomenon is called as self purification of the stream. So you can say this in the Marathi that वन्स कदाचित जर वेस्ट वॉटर नदीत जर सोडलं त्या टायमाला त्याचं बीओडी मिक्स प्रमाण जास्त असतं आणि नदीमध्ये होणाऱ्या पाण्यामध्ये ऑलरेडी नॅचरल ऑक्सिजन असल्यामुळे तो इन्क्रीज होत चालतो आणि बीओडीचं प्रमाण कमी होत जातं. या बीओडीचं प्रमाण आणि इन्क्रीज ऑक्सिजनचं प्रमाण वाढलेलं डिझॉल्व ऑक्सिजनचं प्रमाण वाढतं. या टोटल फेनॉमिननला सेल्फ प्युरिफिकेशन ऑफ अ स्टीम असे म्हणतात. So here is one simple figure or a simple picture from where we can easily understand or deeply understand what are the exact work of self-purification of the steam. So you can see here, this are parameter types of organisms that is mentioned in upper side. Here is the diesel oxygen and here is the biological oxygen demand. So green line, which is mentioned as the diesel oxygen, that is in a ppm, and a biological oxygen demand, which is in a red line. So first we seen here, this is a clean zone of a stream before entering the discharge into the river, before influent discharge into the river. So first this is a clean zone of the river, and in this clean zone you can clearly see here, this is a fish or aquatic life for the fish. At that time there will be oxygen 8 ppm in a clean zone before discharge the sewage here. Is that clear? So this zone, which is already normal clean water organism, trout, perch, bass, mayfly, and the only, it is a very clean zone. And in this zone, diesel oxygen is a 8 ppm. That means it's a higher in the clean zone. But once influent discharge or the wastewater discharge into the stream, at that time we can clearly see here. So at that time, what happened? So biological oxygen demand suddenly increase here, and the diesel oxygen demand suddenly decrease here. So when in first zone, when the discharge of a sewage into the stream, at that time there is a first zone, that is a decomposition zone. In this zone, the minimum fishes can be visible because the dissolved oxygen suddenly decreases and BOD increases. But in a second zone, that is a septic zone. In this zone, in this zone, you can see here the BOD automatically decreases and oxygen curve is increases. This is the second zone of the stream sanitation. In this zone, fish absent fungi, sludge, worms, bacteria. So here is so critical situations for the fish or a fish aquatic life in this zone. So that is very polluted zone. In this zone, so BOD, that is a decreases, and after oxygen is a very minimum in this zone. So a next one zone we can see here, that is a recovery zone. In this recovery zone, oxygen, dissolved oxygen increases in a recovery zone, and BOD are decreases in these zones. That means in the septic zone or decomposed zone, the organic matter consume the oxygen. Due to that, it may decreases, and dissolved oxygen is the increases. In this recovery zone, fish, for the fish, that is the aquatic life. But as compared to its the previous zone, there is a one bacteria in a bacterial process here, fish doesn't have in a safe zone in the septic zone. So in a recovery zone, there will increase the dissolved oxygen, and in this zone the fish can be easily live. So in other next zone, or next zone, that is clean zone. And a clean zone, once dissolved oxygen increases, again BOD is a decreases, it's a normal clean water organism for the fish or other organisms. So you can easily say that it is due to the happen self-purification of a stream. So these three zones are the related to the stream sanitation. And in these three zones, which can be very dangerous as compared to first and the second for the fish life in a stream. So what are the action involved in the self-purification of the streams? So we have clear here what the stream purification. So what can be action there involved in the self-purification of the stream? You can see here dilution. Dilution is nothing but as what? It's the process of to dilute a particular liquid or fluids. That means in Marathi you can see it's a पातळ करण्याची प्रक्रिया. Now second is dispersion due to the currents. That means due to the current, the sewage can be dispersed on in that water. That means पूर्ण वेगवेगळं डिस्पर्शन होतं त्या सिवेजचं, त्या वेस्ट वॉटरचं. So this is one of the action which in a purification of same stream. Then sedimentations. So sedimentations is the when the sewer water is stable, the organic matter can be settled down easily. That is a sedimentation. Then oxidation. Oxidation, once the organic matter decomposition process, once in a decomposition process, that means it may convert in the gases, and this process is called as oxidation. Then reduction. Reduction is the process which can be a decrease BOD and increase the oxygen or dissolved oxygen in the water. That is reduction. Then a temperature. The temperature play a very vital roles in the self-purification of the stream. If a temperature is 0 degrees Celsius, dissolved oxygen is a maximum. But if the temperature increases, the oxygen DO will be decreases. And third one is sunlight. It may be due to the sunlight, it may have chances to the photosynthesis process in the river bottom level, and due to photosynthesis process, there may be chances of the oxygen or dissolved oxygen levels. That is the saturation levels. So these 7 points which be action may happen in self-purification of the streams. The one by one we will see here what are the details of the actions of self-purification of the river. When the wastewater is discharged into the receiving water, dilution takes place, due to which a concentration of organic matter is reduced and the potential nuisance of sewage is also reduced. So it's very simple in a dilution process. Once the wastewater, एकदा की wastewater discharge हा पाण्यामध्ये नदीच्या पाण्यात मिक्स झाला तर there may be chances of a solution or soluble in that water, आणि ते वेगवेगळे होण्यात जे काय ऑर्गॅनिक मॅटर असतात त्या नदीच्या पाण्यात मिक्स झाल्यानंतर ते वेगळे होण्यास सुरुवात होते. This is a dilution process. When the dilution is quite high, large quantities of DO are always available. So it is simple that things dilution is a very high, DO automatically are very high. जास्तीत जास्त जर डायल्युशन किंवा वेस्ट वॉटर पांगल्या गेलं नदीच्या पाण्यात तर ऑटोमॅटिकली DO will increase there, always available, which will be reduce the chance of purification. There is one purification means the word of which can be used for the decompositions. The purification in the Marathi, that is डिकम्पोज होणे, सडणे, ऑर्गॅनिक मॅटर सडणे आणि सडण्याचे इफेक्ट जो काय तो रिड्यूस होणे. बट when the dilution is quite high, डायल्युशन हे जास्त प्रमाणात असेल तर DOचं जास्त प्रमाण वाढू शकतो आणि याच्यामुळे प्युट्रिफिकेशन जी सध्याची प्रक्रिया आहे, जी डिकम्पोजिशन होण्याची प्रक्रिया आहे आणि डिकम्पोजिशन पॉल्युशन होण्याची प्रक्रिया ती कमी होऊ शकते ड्यू टू द हाय डायल्युशन. Then aerobic condition will always exist because the dilution. So once you know that it's a clearer idea, the dilution is the high, a dilution process is going on in a stream at that time. That means it mixes with the oxygen, and once the external oxygen mix with in a dilation process, which is called that aerobic condition. Already many times I told you aerobic and anaerobic conditions, or presence of oxygen, that is aerobic conditions, and this dilution process there is oxygen, that's why it's called as a aerobic condition will always exist because of the dilution. This is about the first action which may happen in the self purification of a stream. Now second action, it may take place dispersion due to the current. So self purification largely depends on currents which are readily disperse wastewater in the stream, preventing the locally high concentration of the pollutants. So you know that self-reduction depends upon the currents. Currents means is flow of water, which readily disperse the wastewater. It should be ready for the disperse the wastewater in the stream, and it may preventing locally high concentration of the pollutants. High velocity improves the aeration. So you know that if the flow of a stream is high, at that time its velocity will be the high. And in such condition, the aeration which reduce the concentration of pollutants. So aeration, the meaning of aeration, the maximum of oxygen in the water, which is just called as aeration. And it that aeration which reduce the concentration of the pollutants. So velocity is high, aeration may be a take place there. That means a mixture of oxygen in water there will take place, and at that time there is a minimum chances to reduce the concentration of pollutants in that stream. So this may happen due to the dispersion action. The high velocity improves re-aeration. Just I told you about aeration, the mixture of oxygen in the river or the wastewater, which is called as aeration. High velocity improves aeration. Velocity can be increased. Velocity re-aeration improves करू शकते, which is reduce the time of recover, though length of stream affected by the wastewater is increases. Length of a stream affected by wastewater is increases. It's a very simple meanings of this sentence. High velocity improves, reaction is takes place, and due to that reduce the time of recovery, the length of stream affected by the wastewater is increases. So it is purely how much long that stream which can be affected with velocity of the rivers. Once the high velocity, it can be maintained the re-aeration process, and due to that re-aeration process to reduce the concentration of pollutants. But it's totally dependent on affected length of a stream, and the length of the stream can be vary with the velocity of the flow. So this is about the second action, that is a dispersion due to the current. Then sedimentation. So if the stream velocity is lesser than the score velocity, score nothing but as the already I told you in the Marathi meaning of score, that is impact on surrounding surface मध्ये घासून घसत जाणे, त्याच्या किनाऱ्याला बँकला नदीच्या किनाऱ्याला घसत घसत जाण्याची जी व्हेलॉसिटी आहे, दॅट मीन्स एंड ऑफ द व्हेलॉसिटी, that is scoring velocity of a particle. Stream velocity is lesser than the scoring velocity at that time. Stream velocity, that is the flow of velocity of the water, and stream velocity is the bank velocity of the water, which is lesser than the scoring velocity. Then sedimentation will be take place, which has two effects. Is that clear? Once sedimentation is to take place, the stream velocity is lesser than the scoring velocity, which has a two effects. The one is SS contributed largely. Suspended solid contributed largely to BOD will be removed by settling, hence downstream water quality will be improved. So suspended solid contributed, this is the first effect, and due to suspended solid settle down in the bottom of the downstream side of the river, at that time BOD will be removed by settling, hence downstream water quality will be improved. Second, due to settled solids, anaerobic decomposition may take place. And if there is absence of oxygen, there will the anaerobic conditions or anaerobic process will be take place, and that time BOD will be removed. This is the third one action of stream sanitations, self-stream purification, sorry. Fourth one action, that is oxidation. The organic matter present in the wastewater is oxidized by the aerobic bacteria utilize the dissolved oxygen of the natural water. Already many times I told you organic and inorganic matter. Organic matter means that those matter having the carbonous material, and that carbonous material which can be oxidized when the oxygen mix with that wastewater, and at that time oxidize that matter, that means decompose that matter due to the bacteria presence, and one bacteria consume the oxygen, the process may be happening oxidize, that may happen in a aerobic bacteria utilize the diesel oxygen for the natural waters. It's a very simple oxidation process. This process continues till the complete oxidation of organic matter takes place. The steam which is capable absorbing more oxygen through the reaeration, etc., can be purifying heavily polluted water in the short time. So once that sewage having the carbonous material or the organic matter, and that in organic matter or microorganism having aerobic bacteria, it can be consumed the oxygen, and once they can be consumed the oxygen, the oxidation process will take place, and due to that oxidation process, the polluted water automatically purify the polluted water in a short times. If you can see in the Marathi, the organic matter मध्ये वेगवेगळ्या प्रकारचे डिकम्पोज होण्यासारखे मॅटर असतात, जे कार्बनेस मॅटर असतात. ते कार्बनेस मॅटर मध्ये मायक्रो ऑर्गॅनिझम असतात, एरोबिक बॅक्टेरिया असतात. एरो बॅक्टेरिया ऍक्च्युअली ऑक्सिजन कंझ्युम करताना, कंझ्युम केल्यानंतर ऑक्सिडायझेशनची प्रोसेस घडते. एकदा की ऑक्सिडेशनची प्रोसेस घडली की तिथे रिएरेशन प्रोसेस होते आणि पॉल्युटेड वॉटर कमी वेळेत प्युरिफाय होतं किंवा शुद्ध होतं. The fifth one action in a self-purification of the stream, that is reduction. Reduction occurs when the stream due to the hydrolysis of the organic matter, stream due to the hydrolysis of organic matter, biologically or chemically. So it is very simple. Reduction may be happen due to what? The reduction meaning of the to minimize the pollutant, to prevent the pollution, to try to purify the pollution. It may happen due to the hydrolysis process of organic matter or the biological process or a chemical process. Anaerobic bacteria will spite organic matter into liquids and gases, thus paving the way for the stabilizing of oxidations. So it's very simple. In aerobic bacteria will consume the oxygen, and at that time organic matter convert into the liquid and the gases, and thus paving the way for the stabilization of the oxidation. This overall process is called as reductions. Sorry, here is not sixth one. There is seventh one. Sorry, correction for this one. Sunlight helps certain microorganisms to absorb CO2, that is a carbon dioxide, and they give out oxygen, thus resulting in self-purification. You know that सूर्यकिरण मायक्रो ऑर्गॅनिझम वर पडतात, ते त्याच्यातला कार्बन डायऑक्सिजन ऍब्सॉर्ब करून घेतात, आणि ऍब्सॉर्ब केल्यानंतर ऑक्सिजन त्याच्यातनं आउट करतात, सोडून देतात. दिस इज ओव्हरऑल प्रोसेसला सेल्फ प्युरिफिकेशन म्हणतात. By helping of the sunlights. Sunlight acts the disinfectant and the stimulates the growth of the algae, which produce the oxygen during the photosynthesis process. So photosynthesis प्रोटीन प्रकाश संश्लेषण क्रियेत तुम्हाला काय करता माहिती आहे, सनलाइट हा डिसइन्फेक्टचे काम करतो. इट कॅन बी स्टिम्युलेट ग्रोथ ऑफ द अल्गी. शेवाळ जे असतात नदीच्या ह्याच्यात ते अल्गी वाढवण्याचं काम करतं. आणि शेवाळची प्रोसेस काय करते, वन्स दॅट अल्गी ऍब्सॉर्ब द सनलाइट, इट मे हॅपन देअर द a photosynthesis process. In the photosynthesis process, you know that they can be produce the oxygen by the algae in presence of a sunlight. This is a photosynthesis process, and that is help to the self-purification of the stream. Hence, wherever there is a algal growth, water contains more DO. So here there is a algal growth of water contains more DO during the daytimes, because in the daytime sunlight has the present, and there is a process of photosynthesis, and in the photosynthesis process growth of algal, And once growth of algal, it may take place the photosynthesis process, and there will be the maximum or more DO during the daytimes. Okay, just I explained this thing in a previous pictorial format, in a 3D pictorial format. This is a DO Sag curve and the physical indices. Zone of pollution, just I explained in a previous 2 or 3 slide, where is a clear water zone, that will be the 100% saturation level of the DO. But zone of a first, that is a degradation or decomposition zone, there will be the 40% of a DO. Is that clear? So in a clean zone, the aquatic life of a fish are the very safe. And when there is 100% of the DO, that is a saturation level DO or a saturated DO. But certainly that saturated DO will be decreases in the first zone of the degradation or decomposition. There may be a 40% of a DO. Is that clear? Now in a septic zone, that is a zone of active decomposition, which can be also as a septic zone. In first zone, that's the degradation, floating of solid, bottom, sludge, color or turbidity, which can be occurred in this zone. But in a zone of active decomposition, there will be the grayish color of that water, darker color due to the CH4, that is a methane, and hydrogen sulfide and carbon dioxide, giving me a grayish color. And that be a gases of the nitrogen, evolution, black scum at the top in this zone of the decomposition. This is a very uh, this is not a safe zone for the aquatic life of the fish in this. But in a next zone, that is a zone of a recovery due to the mixing of oxygen, zone of recovery of oxygen zone. And this zone turbide with the bottom sludge, turbidity with the in the bottom sludge, and the saturation due will be increases. And here can be safe life for the fish or the other of those organs in the waters. And the last zone is a fully clear water with the no bottom sludge, that is 100% deosaturation. So zone of the pollution, we can see here how to clear automatically the action of the 6 point which we have covered in the previous slide. Now, first zone, that is a degradation zone. Already I explained, is situated just below the outfall of the sewer. Water is dark and turbid with the sludge at the bottom. At the bottom, so you can see is at the bottom. This is a first zone. Then there is a 40% of saturation level. CO content of the increases. So here is CO content of the increases. Reaeration slower than the deoxygenation. Here in this process, deoxygenation may be happen. So reaction process is very slow. Conditions are unfavorable for the aquatic life. So already I told you unfavorable by these two aquatic lives, and contains more during daytimes. Hence, where there is algal growth of the water, anaerobic decomposition take place in these zones. Already I told you zone of active decomposition. Already I told you zone of active decompositions. It may happen that in this zone grayish color, darker color may or occur or may can found here, so due to the methane, hydrogen sulfur and carbon dioxide, and it can be evolution of nitrate gases and black scum of the top surfaces. And third one zone, already I explained here. And third one zone, process of recovery starts, stabilize organic matter take place in this zone, BOD falls and the DO content increases, BOD 40% value, NO2, nitrous oxide, CO carbon nitroxide are formed near the end of such type of gases form sulfur oxide on aquatic life for the reappearance. And last one zone, that is a very clear zone as compared to the first zone. Water become a clear, attractive in the appearance, DO rises, saturation level, oxygen balance is attained, recovery is completed, some pathogenic microorganism may be present. And this is one of the last point, deoxygen curve. So this is a saturation concentration of the DO, and this is the downstream distances. And in this case, the dissolved oxygen curve, already I explained in the previous slide. So this is the point of the discharge of by wastewater in this case, and this is a BOD automatically decreases once increases the diesel oxygen here. This is a minimum DO. In this situation, it may be related to the first situation, decomposition or the septic zone, and automatically it can be increased due to the self-purification of water. And this is the first saturation, 100% saturation of the point. Again, it attain 100% saturation of the diesel oxygen in the river. So this curve is called as a diesel oxygen Sag curve, and this dotted curve is called as the BOD decreases curve in the downstream side. So once again, reoxygenation and the deoxygenation. What is the meaning of reoxygenation? The point which can be considered here, that is the influence of the discharge of sewage here. And at that time, before that, saturation DO is 100%. And it may be due to the time, due to the time, due to the time passes, and DO content in a percent, and due to time passes, it may get to the sagging of this curve process. That means the deficit of the curve in this case, and again it can increase 100%, attain the 100% of the oxygen of Sag curve. In this case, there are the again two curves we can see. This is a deoxygenation curve. You know that once the effluent discharge into the water at this point, that time is 100% DO, but it consume the oxygen by the organic matter present in the sewage. At that time, the oxygen level is the decreases, and this decreases oxygen level, which is called the deoxygenation of the curve. And another may be happening is that vice versa, the recovery stage, due to the mixing of in aerobic condition, oxygen reoxygen curve, that may consume the oxygen or increase the oxygen due to the mixing of uh, self purification action in the stream. At that time, that is called as a reoxygenation curve. In Marathi, you can say that the वेस्ट वॉटर नदीमध्ये मिक्स केलं तर टायमाला 100 जर असेल तर ही सॅच्युरेशन डीओ लेवल जाऊ शकता. पण सॅच्युरेशन लेवलचं डीओ डिफिसिटमुळे कमी होऊ शकते, कमी होते, कारण जे ऑर्गॅनिक मॅटरमध्ये बॅक्टेरिया असतो तो डीओ कन्झ्युम करून घेतो आणि बेडू लेवल वाढवतो. कंझ्युम केल्यामुळे ऑक्सिजनची लेवल कमी होते, पण पर्टिक्युलर झोन नंतर ती परत ऑक्सिजन लेवल वाढते. ॲज कम्पेअर टू या फिगरमध्ये किंवा या ग्राफमध्ये अजून दोन कर्व्स आहेत, ते म्हणजे हे कर्व डिऑक्सिजनेशन कर्व. जस्ट आय टोल्ड यू, ड्यू टू द प्रेझेन्स ऑफ द ऑर्गॅनिझम बॅक्टेरिया, ऑर्गॅनिक बॅक्टेरिया, इट कॅन बी कन्झ्युम द ऑक्सिजन, डिझॉल्व ऑक्सिजन. ॲट दॅट टाइम ऑक्सिजनची लेवल कमी होते, त्यालाच आपण डिऑक्सिजनेशन कर्व म्हणतो, सेकंड. आणि ॲट दॅट टाइम झोन 3 आणि 4 मध्ये ऑक्सिजन लेवल वाढते, which is called as a reoxygenation curve. So when the pollution load is discharged into steam, DO goes on as reducing. This process is known as a deoxygenation. It depends upon the organic matter present at the temperatures. Just you know that DO, diesel oxygen purely depends on the temperature. Just I told you, if the 0 degree Celsius temperature at that time, 14.6 mg per liter DO are the presence. So you can say here, if the 0 degree Celsius temperature असेल तर at that time 14.6 milligram per liter temperature per liter डिझेल ऑक्सिजन असू शकतो. तेच जर 20 डिग्री सेल्सिअस जर झालं तर तो 9.17 mg पर लिटर असतं. आणि तेच जर 30 डिग्री सेल्सिअस टेम्परेचर झालं तर डीओचं प्रमाण 7.6 milligram per liter असतं. That means when the increase the temperature, at that time DO will be decreases, and when the decreases the temperature, DO will be the maximum up to the 0 degree Celsius of the temperature. So variation of depletion of DO is represented as graphically deoxygenation curve. The variation of depletion of a diesel oxygen, which is called deoxygenation. So at the same time, oxygen get added into the steam through the various processes such as photosynthesis rain. The curve representing oxygen getting process known as reoxygenation, and the re-aeration curve. In a running polluted stream, deoxygenation and the reaction process go hand in hand. Deoxygenation is more deficit results. So the amount of DO deficit can be obtained by the graphically adding the both the curves. The resultant curve is known as the DO Sag curve. So just I already we Seen here, this is a resultant curve after mixing of these two curve, reoxygenation and deoxygenation. So we can easily determine the DO deficit. DO deficit मतलब तर कमतरता कमी होणे. Deoxygen काही कसं कमी होऊ शकतो? DO deficit that is equal to saturation DO. Saturation DO, you can see this. This is a saturation level of the DO. Saturation DO. Minus actual DO. Saturation DO is purely depend on the temperatures and organic matter present in the sewage. Once temperature are the increases, saturation DO will be the decreases, and temperature is decreases, saturation DO is the increases. The saturation DO minus actual DO, that is equal to DO saturation minus DO actual. So we'll get the DO deficit here. In detail, the Stefer-Phillips equation can be used for the analysis of DO Sag curve. That is in our syllabus. Its derivation or its numerical is not in our syllabus. For getting more knowledge about the DO Sag curve, please refer the Stefer-Phillips equation on YouTube. You will get the ideas of how to DO deficit may happen due to the increase in the temperature and decrease the DO. Increase the DO, decrease the temperatures. Overall, uh, this phenomenon explained by the Streeter-Phelps scientists in that case. So you can see on YouTube. So river classification as per the Ministry of Environmental and the Forest Department or Central Government Department of India, that is river classify into the four stage or four class, that is A class on the basis of their sources, second class that is classified on the basis of their permeability. Permeability, that is means it may be a flow for the overall years, that means it may flow for the overall seasons. Then C on the basis they are the water utility, and D classify on the basis of their ecology. So thank you for today's lecture. Thank you very much.